Hello, dear students, and welcome back to the GCE Maths panel online. In this particular video, we are focusing on circles. We urge you to watch this video to the end, as we have so much that has been packaged and prepared for you. Please watch this video to the end and don't forget to subscribe and to share this video. Stay with us throughout. And you can equally leave your comments below, or you go to our blog at www.gcemathspanel.blogspot.com, where you can join us for other programs and preparations for the GCE. We wish you the best and stay tuned. So what, first of all, is a circle? A circle is the locus of the set of points Px, y, whose distance from a fixed point, that is the center, AB, is constant. So the distance of every point on the circumference from the center of the circle is what we define as the radius, r. And this distance is constant all through, from all points to the center. This distance is constant. So for example, here we have a circle, and the center of this circle is denoted by C with coordinates AB. And here we have a point on the circumference. Let's call this point XY. The distance between this center and this point gives us the radius of the circle. And we can equally obtain the radius of this circle by using Pythagoras' theorem, because this will form a right angle triangle, as we are going to see. So using Pythagoras' theorem, we are going to have Pythagoras' theorem together with coordinate geometry. We will have r squared to be given by x. Change in x is along the x-axis. We have x minus a, so x minus a squared. This is the distance, and this other distance is y minus b squared. And this angle here is a right angle triangle. So this angle here is 90 degrees, and this triangle is a right angle triangle. So we have the sum of squares of these other two sides for a right angle triangle should be equal to the square of the hypotenuse. So from here, r squared will be equal to x minus a squared plus y minus b squared, giving us r squared. So these are some properties of a circle. Let's denote this equation number 1. And one important thing about this equation is that this form of a circle is called the Cartesian form of a circle, or the Cartesian equation of a circle. So in an exam, when you ask for the Cartesian equation of a circle, this is how you should state it. You state it in terms of the center and the radius form. So still that definition, thus the equation of a circle with center minus 4, 1 and radius 2 from this definition will be given by x minus the x value of the center. So x minus minus 4, because there's already a minus sign here. Now with this minus sign squared, plus y minus this y value here, y minus 1 all squared, should be equal to the square of this radius. So we can simplify this to have x plus 4 all squared plus y minus 1 all squared to be equal to 4. So the Cartesian equation of a circle that passes through the points with center minus 4, 1 and has a radius of 2 is given by x plus 4 all squared plus y minus 1 all squared equals 4. Now, these are some things that we have to take into consideration. Let us have a small exercise here. Some of these exercises have the answers at the end of this video, which you can see, or you can equally visit our blog, www.gcemathspanel.blogspot.com, where you can have more of these videos, and we equally have short quizzes there that you can go through for the various subjects to prepare yourself for your exams, be it ordinary level or advanced level. So the first exercise here is to state the equation of the circle with center and radius C and R respectively in the following cases. So we have these 4 equations. So you can easily state the equations of the center and the equations of the circle with center and radius given for each of the equations. The next thing Okay, exercise 1B. Equally, they can decide and give you the Cartesian form of the equation of a circle, and they ask you to state the center and the radius of that circle. So this should not be actually something difficult. So you just do exercises. Don't watch mathematics to go and write the GCE. I emphasize, don't just watch this video. At the end of this video, it is very important that you solve all of these exercises. I am actually not just advising you, but I am emphasizing. Okay? So don't just watch and solve all the exercises, all the examples that are done in the videos, you solve, because this is how online studies is done. If you just watch the videos and you don't do the practice, which is drill and practice in mathematics, then you are just wasting your time. You are wasting your time. All right. Now let's look at the general form of the equation of a circle. So from equation 1 above, the Cartesian equation of a circle, we can look at it in terms of this perfect square when it is expanded. So when we expand that perfect square, this x squared, x minus a all squared plus y minus b all squared equals r squared. So when we expand this Cartesian equation of a circle, we are going to have the general form, but with some small modifications, as you have seen in your textbooks and as your teachers have taught you. So when we expand x minus a all squared, we are going to have x minus 2x, that's x squared minus 2x plus a squared. Now y minus b gives us y squared minus 2by plus b squared is equal to r squared. So the terms with squares, the variables, that's x and y squared, you can bring them together by rearranging. So we have x squared plus y squared. Now the ax term, so minus 2ax, the one who would y, minus 2by. Now all the constants. Now plus a squared plus b squared minus r is equal to 0 on the right-hand side. So we want to work with this Cartesian equation of a circle to come out with the general form of a circle, okay? So this will be equal to 0. Now, we can rewrite this as follows. We have x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So we have rearranged all of this. We have replaced minus a by plus 2 by plus g, replace minus b by plus f, and a squared plus b squared minus r squared by c. So this is what we have done. The general from a, or g is equals negative a, f is negative b, and c equals a squared plus b squared minus r squared. So when you're given the general form of the equation of a circle, you can obtain the center and radius as follows. With this general form in this box, the center of the circle will be given by negative g, negative f. Why? Because you see that we have replaced g by negative a, right? So normally the center is supposed to be a, b. But now that we have replaced a with negative g, or we have replaced negative a by g and replaced negative b by f, the center of the circle is now at negative g, negative f, and the radius will be given by the square root of a squared plus b squared minus c, the positive square root, okay? Yeah. So let us call the general form of the equation of a circle equation 2. Equation number 2. All right, guys, don't forget to subscribe to this channel and to share these videos with your friends. You can get to our blog where we have some questions and a lot more of GCE just for you. So let us recall, what's the general form of the equation of a circle? Speak with me as you watch. X squared plus y squared plus 2 what? 2gx plus, yes, 2fy plus c is equal to what number? A constant 0. Where we have a, b, and c, as well as r defined as follows. The center is negative g, negative f. Please remember that it is g that comes with f. You know that in the alphabet, f comes with g. But with this circle, we are using negative g, negative f. Negative g first, negative f, after. So very important remarks about the equation of this general equation of a circle. From the general form of the equation of a circle, this one above, you have to know the following. The first point is that the coefficients of x squared and y squared must be the same. And the degrees of x and y must be 2. So you must have x squared and y squared. And the coefficient of this x squared and y squared must be the same. So if x is -2, y should be -2. The coefficient of x is -3, coefficient of y must be -3. The coefficients must always be the same. If they are not the same, it is no more an equation of a circle. It might end up being a hyperbola, parabola, or whatever. The second very important point you must note is there must be no term in x, y. There should be no x, y term for this general form of equation of a circle. If there's an x, y term, it's no more a circle. Okay? It's no more a circle. It should normally end up being a parabola, a hyperbola rather. The next important point is we can find the center and radius by completing the square or by equating coefficients. So with this, we can find the circle and radius by completing the square or by equating coefficients. Even to convert this equation back to Cartesian form, we can equally use completing the square, or we can do equating coefficients. We find the values of A, B, and R, and then we substitute in that Cartesian equation. So exercise 2A, state in each of the following cases why these are not circles. Why is this first one not a circle? You find out yourself. Why is the second not a circle? You still find out. And the third, obviously, you know the answer. You will find out for yourself. Good. This brings us to the next part of the discussion. Let us look at some examples. Find the center and radius of a circle x squared plus y squared plus 8x minus 2y plus 13 equals 0. We are going to be employing two methods here. In method 1, we'll do comparing coefficients. We'll compare the coefficients. Normally, this is what most students, as we have been seeing, most students use comparing coefficients to find the center and the radius. So from here, if you compare coefficients, we will see that plus 8x, or this should be equal to 2gx. So from here, the coefficient of x is equal to 2g. Always remember. So 2g is equal to 8, and the coefficient of y should be equal to 2f. So our g is 4, and our f is equal to -1. Remember that the center of a circle is -g, -f. So from here, the center is -g, -f, which implies -4 plus 1. And the radius is equal to a squared plus b squared minus c, the root of that. So this gives us 4 squared plus -1 squared minus 13. And that gives us the square root of 4. And we take the positive square root, as we said before, the positive square root. So these are the center and the radius of this circle, respectively. In the second method, we are looking at completing the square. You have to pay more attention to this one if you decide to use this method. So completing the square, you have x squared plus y squared plus 8x minus 2y plus 13 equals 0. So I'm going to be completing two squares to have this general form of circle, but I want to have it some sort of x minus a squared plus b minus y squared, y minus b squared is equal to r squared. In that Cartesian form, right? So from here, I can identify that x squared plus 8x can be brought together like this. So we have 8x squared plus 8x. I bring these terms together. They have y squared minus 2y. This is y squared minus 2y together, and then this is 13. I can identify the squares from here and do rearrangements. I know that x squared plus 8x plus 16 is a perfect square. Yes, you have seen this in grade 11 and in grade 12. That is lower seat and upper seat, right? So I know that if I have x plus 4 all squared, it's going to give me x squared plus 8x plus 16. So I'm going to add plus 16 here, separate this one. This plus 16, I'm making this one a perfect square. The same thing with y. I know that y squared minus 2y plus 1 is also a perfect square because y minus 1 all squared, when expanded, will give y squared minus 2y plus 1. So this 16 that I added here, I'm subtracting the 16 back so that you should not ask me that why did I add 16? So I've not changed anything in this equation, right? Now let's do the same with the y. We have y squared minus 2y plus 1. I've added 1. I'll have to subtract the 1 back. Now I continue with this my equation. This is 13 here. So plus 13 is equal to 0. Now all these terms outside the brackets, I can simplify them. So normally x squared plus 8x plus 16 is x plus 4 all squared. And y squared minus 2y plus 1 is y minus 1 all squared. I can bring minus 16 here, minus 1 plus 13. That gives me minus 4. If I take it to the right-hand side, it becomes plus 4. As if I add the minus plus 4 to both sides. So now with this form, I have it in Cartesian form. From here, the radius is the square root of 4, and the center is minus 4 plus 1. This is in Cartesian form. Hence, the center and the radius are respectively minus 4 plus 1. So it's that the two methods give the same result. So it depends on what you would like to choose. But if you are not very powerful in mathematics, I advise you to use the first method. Okay? If they ask you to get this Cartesian equation. Now, this second method may also be very sweet if they ask you to give the Cartesian equation and the center and the radius at the same time. So this one you can just trash all. Though you can see this other method is the same thing. All right. There is more. You're still at the introduction. Find the center and radius. This is another example of the circle. Minus x squared minus y squared plus x minus 3y minus 1.5 equals 0. So quotient, look at this equation very well. We start by making the equations of x squared and y squared to be positive and preferably positive 1. So method 1, by comparing coefficients, minus 1 should be equal to 2g, and 3 should be equal to 2f. So the center is minus g minus f, so it's 0.5 minus 1.5, and the radius is 0.5 squared plus minus 1.5 squared minus 1.5, which is our c here. That gives us 1. For method 2, completing the square, you have x squared plus y squared. I first of all multiply all through by negative, minus x plus 3y minus, that's plus 1.5 equals 0. Now I have x squared minus x. So I know that x squared minus x, I can bring this together, and then y squared plus 3y together plus 1.5 equals 0. Now I equally know from completing the square that x minus a half of squared is the same as x squared minus x minus a quarter. And y plus 3y plus a certain number. And what is that number? That's 3 on 2 squared, right? It's also a perfect squared. So I'm subtracting this 1/4 back. So you will not ask me where this 1/4 is coming from. Why did I add it? I've not changed anything in the equation. Y squared plus 3y plus 9 on 4. This is from completing the square now in quadratics. Okay. So I subtract this minus this 9 on 4 back and continue with plus 1.5 equals 0. And now bring all of this together, x minus a half squared plus y plus 3 on 2 squared. And all of that should be equal to 1 on the right-hand side. So from here, the center is a half, and that's a half minus 3 on 2. And the radius is 1, just like the previous examples that we saw. Okay. Take your time and watch this video. For you to follow us live every Sunday or to attend our preparatory classes, please go to the GCE Preps platform and you log in there. It is free. You register. It is free, and you attend the class live videos. You can talk to the teacher can talk to you. They give you notes and all of that. We have quizzes that can be taken there. And remember that the GEPP is working together now with the GCE Maths panel. And other classes can equally attend it from the GCE Maths panel blog. If you're stuck, go to www.gcemathspanel.blogspot.com, where you have past GCE equations, and you can equally see the link there to join our classes and the timetable. If you cannot see the timetable, move on to the GCE Preps platform and their website. You are going to see the timetable. If on your phone, you click on that link and you see that it's not showing, select web view and you're going to see the page completely. If you're using a laptop, you're not going to have a laptop or a tablet, you're not going to have any difficulty. Another example, find the center and radius of the circle, this. So the first thing to do here, like previously, you have to divide all through by 2, make the coefficients of x squared and y squared to be the same. If you are using completing the square or any other method, because if you just go directly, you will just fall into repeat. Okay. So this example, you have just multiply all of this circle by 2 so that we can emphasize on this. Yeah, we can start making no difference if you divide all through by 2. So from here, we have our center also to be 1 minus 3 and the radius to be equal to 4. Method 2, that's my focus. After we divide all through by 2, this is what we're going to obtain. And we use the previous methods that we have used. We do the same like previously. And we end up with x minus 1 all squared plus y plus 3 all squared equals 16. Hence, the center of the circle is 1 minus 3 and the radius is 4. Now let us look at something else after some exercises. You can equally go to Math 24 Super Channel. At Math 24 Super Channel, you have a lot of videos too on mathematics that will help you to prepare well for the GCE. Be it yourself being here in Canada or there in the US or back there in Africa, in any other African country, you can find all of this material online. Exercise 2B. State the center and radius of the following circles: x minus 1 all squared plus y minus that. All of these circles. We have discussed all of them during the class. So make sure you answer all of these questions, and if you have any issues, submit them below in the link, okay? So you can submit them below. And don't forget to subscribe to this channel and discuss. Invite others to friends to attend this class with us online. Let's discuss about tangents and normals to circles. Tangents and normals to circles. So if the point C with coordinates x1, y1 is a point on the circumference of a circle, and OAB is the center of that circle, and then the line OT is a normal, while the line AB is a tangent to the circle. Let us sketch this and see what you're talking about. So if O is the center of the circle, and T is a point on the circumference, then this line from O to T, this radius, is a normal to any line that touches this circle at this point. So here's a tangent. A tangent is a line that touches a point, that's a straight line, at just one point, as they say it. Now, a line that leaves from this point where the tangent touches the circle to the center of the circle is called a normal. So according to this circle, the line OT is a normal, and the line AB is a tangent. And the angle between a normal line and the tangent line to a circle is 90 degrees. Now let's see how we can work with this relationship to find the equation of a line passing through a given point with center this, radius that, or circumference, whatever. So the gradient of the normal, you can have the gradient of the normal directly, or you can decide to differentiate if there's some sort of differentiation that can be done. When you differentiate, you have the gradient of the tangent. So the gradient of the normal can be given by, let us look at it. We have seen it before in coordinate geometry. change in y over change in x. So we have y minus b, or y1 minus b, all over x1 minus a, because I define in terms of x1 and y1 the points t. And this is the gradient of the normal. Now the gradient of the tangent, which is actually a perpendicular to the normal, is given by -1 over the gradient of the normal. So gradient of tangent is equal to the negative reciprocal of the gradient of the normal. So gradient of tangent is equal to the negative reciprocal of the normal's gradient. So -1 over the gradient of the normal. That's the gradient of the tangent. This one we are not using differentiation. Okay. Can equally differentiate. And let's see what we have. So if given the equation of the curve, we can as well differentiate implicitly to obtain the gradient of that tangent at point C. So let's take an example. Given that the circle x squared plus y squared minus 2x plus that, find the center and the gradient of the normal at 0.51 and the gradient of the tangent at 0.51. Also find the equation of the normal that passes through the 0.51 and the gradient of the tangent that passes through that same point. This is a very good question. So we can get the gradients of the normal and tangents and the equations of the normal and tangent at the point 5, 1. All right, so let's move it. All right, so this is the same question. So the first thing, we are given this equation. Let's start by find the center. The center, when you look for the center here using those methods we have used before, the center of 1 minus 2. Or you can just say minus 2 divided by 2. It's minus 1. You take the minus, the negative of it, and the same with this other one. Now find the gradient of the normal. Gradient of the normal will be given by, since we already know the center, right? Gradient of the normal will be given by change in y over change in x. So we have 1. This is a 0.51, right? So we have 1 minus 2 over 5 minus 1. So that gives us 3 on 4. Therefore, the gradient of the tangent will be equal to -1 divided by 3 on 4. We can now find the equation of the normal at that point, which will be given by gradient of normal into x minus x1 plus y1. X1 here is this 0.5, and our y1 is a 0.1. Similarly, the gradient or the equation of the tangent will be given by, the only thing we are going to change here is this gradient. -4 on 3 into that plus that. So this is what we actually have. And so we can equally decide to use implicit differentiation to answer this same question. So for equation of tangents, do not use the center because the center does not lie on the tangent. Now, since we have the center of this circle, one mistake that students will make is that to find the equations of the tangent and normals, they're going to use this point. Please do not use this point because this point does not lie on the tangent. It lies on the normal, but not on the tangent, okay? So it's better to use this point. The other point that lies on the tangent go for both cases, but this one will not go. Alternatively, we can get the gradient of the tangent by implicit differentiation as follows. So we differentiate implicitly. If you do not understand how to differentiate implicitly, I'll just do it here, but we can get to our previous videos on differentiation and you see implicit differentiation. Can go to GCE Math panel on YouTube and you get these videos there, or you go to GCE Math panel on Google Sites and you see the notes there as well. So let's differentiate this implicitly. When you differentiate 2x, you have x squared, you have 2x. Differentiate y squared, you have 2y dy dx or 2y y prime. So minus 2, when differentiate this, minus 2. Differentiate plus 4y, you have 4 divides the x or 4y prime. Differentiate minus 20, you have 0, it's a constant, so all of this is equal to 0. You now make y prime the subject of the formula. So we have a 2y plus 4, that's factorizing. All of that y prime should be equal to 2 minus 2x. Now y prime or divide the x will be equal to 2 minus 2x over 2y plus 4. So at the 0.51, normally you can factorize and simplify. At the 0.51, this divides the x or the gradient of the tangent will be given by 2 minus 2 into 5 all over 2 into 1 plus 4. And this gives us minus 4 on 3. Can you see? Which is the same gradient that we had here before. Minus 4 on 3 gradient of the tangent. And from here, we can just multiply by, we can take the negative reciprocal of this, and it will give us gradients of the normal. This is very important. Okay. Now we have this exercise, find equations of the tangents and normals at the given points. All right. I hope, as I've said, when you are studying online, especially with subjects that have to do with drill and practice like mathematics, physics, and so on, make sure you don't just watch the videos, you solve all the examples again. You have to solve the examples again. Otherwise, you just be wasting your time and watching movies. You'll not actually be studying, you actually just be watching a series. So solutions will be discussed during class for this one. If there are any issues, go to gcemathfind.blogspot.com. You see a timetable for classes there, and you discuss it in class. Or you can go to the GCE Preps, P-R-E-P-S platform, GCEPP, www.gcepp, and you can get the timetable there too. The next thing we discuss about is the distance of a line from the center of a circle. The distance of a line from the center of a circle. Let us consider the line. Let L1 be a line, alpha x plus beta y plus gamma, and also C1, that is gamma, is equal to 0. I'm sorry, this is equal to 0. And the circle of radius. So you have a circle whose center and radius are given respectively as R, AB, and R. Okay. So let us look at this line. This is it. Let us discuss it. So this is a circle. The center is AB. And we have this line that is far away from this circle. The line is L. So here we're looking for the perpendicular distance from the line to the center of the circle. The perpendicular distance of the center of the line of the circle from the line is given by the formula d. That distance is d is equal to alpha. We replace x by the center, x coordinate of the center of the circle, plus beta. We replace y by the y coordinate of the center of the circle, now plus this gamma. All this over the square, the sum, the root of the sum of squares of the coefficients of the line. That's x and y only. And this is something that you also do when you're working with space vectors. When you're working with space vectors, that's vectors in 3D. It is this same formula. The only extension is that we are working. You now use we now extend up to z, and the denominator we have alpha squared plus beta squared plus another thing again squared, the root of that, to have this distance from a point to a plane. Okay. So the same procedure. So note, if this distance is equal to the radius of the circle, then we say the line is a tangent to the circle. So if d is equal to r, it means that this line must be touching the circle somewhere. So at times you're asking an exam to prove that a line is a tangent to a circle, you just have to find the distance of that line from the center of the circle and compare it to the radius. If that distance d is equal to the radius, then that line is a tangent to that circle. Okay, let us take an example. So we are given the line 3x minus 4y plus 14 equals 0, and the circle x squared plus y squared plus 4x plus 6y minus 3 equals 0. To find the distance of the line from the center of the circle and to show that the line is a tangent to the circle. So first of all, our center of this circle is -2 minus 3, and our radius is equal to 4. Therefore, our distance, which is given by the absolute value of, so we have this, look at the line. So the coefficient of the line, you have 3, -4, and 14. This is 3, -4, and 14. Now we replace the x and y values by the coordinates of the center of the circle. So we have replaced x by -2 and y by -3, okay? All these are the sum of squares, the roots of the sum of squares of the coefficients of the line. So this is going to give us 20 on 5, which is 4. And equally, the radius of this circle is 4, as we just saw up here, the radius is 4. So the distance equals the radius, and therefore, this line is a tangent to this circle. This line is a tangent to this circle. Okay, don't forget to subscribe to this channel as we're coming to the end of this lesson. We have a lot of A-level lessons for you. We have model GCE quiz and GCE quiz in other countries, WAEC and all this other stuff. Okay, GED. So now let's look at the distance D from a point to the point and the line to the center of a circle. We have these exercises to do. Please make sure you answer these questions. It is only by answering these questions that you will find out if you have studied and grasped something. If you do not answer them, you are just watching a movie here. Mathematics goes with real and practice. So the last part of these lessons will be on intersecting, orthogonal, and touching circles. We will look at internal and external touch. So if you look at these two circles are touching externally. You can see they're just grazing each other here, so they're touching externally. And for external touch, there's a formula that we use to find out if two circles touch externally. Those are their centers, right? So the sum of their radius, of their radii rather, should be equal to the distance, the center to center distance. Center to center distance means the distance from one center to another. So if this center to center distance goes to the sum of their radii, then the circles touch externally. Now, internal touch. The circles touch internally. This is internal touch, let me show. They are just grazing each other, but one circle is inside the other. To prove that two circles touch internally, we have to look for their two radii first of all. Then what we do. If their center to center distance is equal to the difference, the first one of the sum for external touch, for internal touch, it is the difference. Bigger one minus the smaller one. If this occurs, the distance to the center distance is equal to the difference in their radii, then the two circles touch internally. Now, how can we prove if two circles are orthogonal? Orthogonal means that they meet at right angles. Look at this diagram, they meet at 90 degrees. This angle is 90. You can equally draw it down this way, also be 90. So two circles are orthogonal if the square of their center to center distance is equal to the sum of squares of their individual radii. Their center to center distance squared is equal to the sum of squares of their individual radii. Now, for non-intersecting circles, consider they do not even touch at all. The R1 plus R2 is strictly, the distance, center to center distance is strictly greater than R1 plus R2. So this is how you can prove that they do not intersect at all. To find the point of intersection, we equate the two circles and solve X and find their corresponding Y values. So now determine whether the circles touch internally or externally. This is an example, or they are orthogonal. So we have these two circles, C1 and C2. We want to determine if they touch internally or they touch externally or they're orthogonal, or maybe they do not even intersect at all. So let us test the following. First of all, find their center and radii for the first one. it is 1, 3 for the center, and the radius is 3. The second circle, the center is -2, -1, and the radius is 4. Now let us start testing. What's the center to center distance for these two circles? The center to center distance is 5. Now case 1, let us test and see if they touch externally. R1 plus R2 is equal to 7, right? And that 7 is not equal to 5, which is the center to center distance. Therefore, these circles do not touch externally. Let us look for internal touch. R2 minus R1 is equal to, that is 4 minus 3 is 1, which is not equal to 5. So these two circles also do not touch internally. This one example touch, it's like 4 examples in one. Let us test for orthogonality. Center to center distance is 5. So 5 squared is equal to 25. R1 squared plus R2 squared is also equal to 25. So it's that these circles are orthogonal. They meet at right angles. Now remarks, two circles touch at only one point if distance equal to R1 plus R2, that's the center-center distance, or if the center-center distance equals to the difference in the radii. Now, so there are two cases, there are two things that can happen if two circles touch at just one point. So they can either touch internally or externally. So you show that circles touch at just one point. What you do is that you check for internal touch and external touch before you conclude, okay? And please solve more examples. Now show that the circle, this and this other circle touch each other. I want to show that these two circles touch. So first of all, C1 has center, the first circle, 8, 6, circle, and has radius 5. C2 has center 16 on 5, 12 on 5, and radius 1. Now, the center to center distance for these two is 6. So R1 plus R2 is equal to 6, which is equal to Z. So what can we conclude? Therefore, there is an external touch. If R1 plus R2 is equal to center to center distance, then they touch externally. So note, it is best to equate when coefficients of x squared are both 1. So it means that if I have to equate these two circles, that's to get the common point of intersection, the coefficients of x squared here in this first circle and the coefficient of x squared in the second circle should both be 1. Now equating. So I should not have a more complex equation because I'll still have an equation in terms of x squared and y squared, and it might not be very cool. Yeah. All right, so we equate the two circles and we solve for x. Make x the subject of the formula and we substitute. And that is it. All right, show that x squared plus y squared minus 4 equals 0 and that touch each other. Find the point of intersection. So this one is the same thing. Yes. So we solve this one. You have to find the center and radius of the first circle, center and radius of the second circle, the center to center distance. And here, you start these two circles touch externally. So you can find the common points of intersection. So when we equate, we are going to have -4 is equal to -2x minus 2. You equate these two circles and x equal to 1. So from here, we can also solve for y. Y will have two values, plus or minus √3. So at the end, these are the results that we have. With parametric equations of a circle, we have looked at the general form, we have looked at the Cartesian form. What about the parametric form? So normally, this is the Cartesian equation of a circle. And if this is the radius of this circle, then this side should be given by, and this is the angle theta. The angle that, the side that is holding this angle together with the the hypotenuse is always has the cos, okay? This angle exists here, so this line should have the cos. So this line should be r cos theta. Why is the other one that does not have the angle at this point between the hypotenuse and this line? The angle is not here, so it takes sine. So this r sine theta, or the same as r cos 90 minus theta, which is the same as r sine theta. So this equation can be given in parametric form as x is equal to r cos theta and y is equal to r sine theta. That's the parametric equation of a circle. Let us look at it in details. So from here, we know that this is x minus a squared compared to the other one. This is the x minus a squared. So that's r cos theta all squared. This is y minus b all squared, which is r sine theta all squared is equal to r squared. So from here, x minus a is equal to r cos theta. And therefore x will be equal to r cos theta minus a, plus a rather. Equally, y minus b is equal to r sine theta. So from these two, we can see that for the parametric equation of a circle, it can be given by x equals to r cos theta plus a, where a is the x value at the center of the circle, and y is equal to r sine theta plus b, where b is the y value at the center of that circle. So this is what we have for the parametric equation of a circle. Let us take some few examples on this. A circle has parameters x equals 3 cos a and y equals 3 sine a plus 4. State the center of the center and radius, and find the Cartesian equations of the circle. So from here, what is the center? X equals 3 cos a plus, there's nothing. So the center, the x value is 0. Y is equals 3 sine a plus 4. So this plus 4 is the y value at the center of the circle. Now for the radius, just get the coefficients of cos a and sine a. So the radius will just be the coefficients, which is 3, right? So the radius is 3. So from here, you can have the Cartesian equation of the circle directly. That is x minus a. So we have x minus the center, all that on the radius, plus y minus the y value at the center, all that on the radius, all squared, to be equal to 1. Equal to 1. Or you can just say it directly. X minus 0 squared plus y minus 4 squared is equal to the radius squared, equal to 3 squared. There's no problem with that. So yes, this is it. You can express now like this. So another example, a circle has center minus 1, 5 and radius 7. State the Cartesian equation and the parametric equations of this circle. So from here, the Cartesian equation is just x minus 1 squared plus y minus 5 squared, which is equal to 7 squared, which is 49. And from here, you can have the parametric equation, right? So the parametric equation here will be given by x is equal to 7 cos theta plus minus 1, and y is equal to 7 sine theta. Now plus 1 or minus 1, so plus 5. Okay. Yeah. Now find the parametric equations of this other circle here. So this one, the radius is 3. The radius squared is 3. So x, the parametric equation will be root 3 cos theta plus the center is 1 plus 1, and y will be root 3 sine theta. The y value at the center of the circle is minus 2. So that's the parametric equation. So these are some of the solutions to the few exercises that we had, and you can also go to Maths 24 Super Channel to get more, and move to the GPP to attend live classes. Don't forget to go to the gcematpanel.blogspot.com to have more information. Thank you so much for staying tuned to the GCE Math Panel. Our next chapter is on sequences and series. Don't forget to subscribe, to share this with your friends, and to watch this very good video. Thank you so much. It has been the GCE Math Panel, Math 24 Super Channel, and the GPP. Bye. Bye.